it. So once a year, you and I try to go up. All right, today we're going to talk about isosceles and equilateral triangles. Okay, we're trying to figure out what special relationship exists among the sides and angles of isosceles and equilateral triangles. How are we going to do this? We're going to prove theorems about isosceles and equilateral triangles and apply properties of isosceles and equilateral triangles. Okay, key vocab to get down today: the legs of an isosceles triangle, a vertex angle, a base, which refers to the base side, and then there's also another thing called the base angles that we will talk about. Okay, a couple more minutes to write this down.
Wait, I'm on the last one.
Okay, we'll come back to it, guys. We'll come back to it later on. Okay. All right. First off, first thing up. Okay.
Write all of that down.
We talked about this in the warm up. I'll tell you what to write down. Just give me a second. Okay. Sides up here. An isosceles triangle has at least two congruent sides. Okay. So it can have more, but it has at least two congruent sides. Right? We call the congruent sides the legs of the triangle. And get this, the vertex angle is the angle that is formed by those congruent legs. Okay? The vertex angle is the angle that is formed by the congruent legs. The side that is opposite the vertex angle is called the base, which means that the two angles that have the base as a side are called the base angles. Ton of vocab right here, right? A ton of vocab. But what you got to get down when we're talking about isosceles triangles, right? Figure out which sides are the legs. How do I know which ones those are? The congruent sides are the legs. Okay? The angle that is formed by the legs is called the vertex angle. The side that is opposite the vertex is called the base, which means that the two angles that share the base are called the base angles. Let's see how we're doing with all this. Okay, this takes us back to last week a little bit. The base side, okay, the base side, label it for you guys. Call this A, B, and C. I'll tell you what, let me change my question. Which sides are the legs here? B and C. Remember, what the legs of an isosceles triangle, what's special about them? They are what? They're congruent. They're Foster. The base sides are congruent, correct? No. What are congruent? What do we call the congruent sides? The legs. Okay? The other side is called the base. All right. Remember this vocab from last week? Is side A included or excluded between the base angles? Included. You guys remember angle, side, angle? Correct? Angle, side, angle, where the side was included between two congruent angles, right? Angle, side, angle. Last week, see that? That's the easiest way to remember what the base side is. It is the side that's between the congruent angles. Right? included side. Okay, included side. Remember our triangle proofs last week? Talking about triangle congruency. We had side by side, side and side, angle side, angle, angle, angle side, hypotenuse side. And the difference between angle side angle and angle angle side is that congruent side in the two triangles and angle side angle is included between the angles. But an angle angle side is not included, it's an excluded side. Okay. All right, a couple more seconds. We gotta move on. We'll come back to it at the end, okay? All right. Let's talk about our isosceles triangle theorem here. Here's what we need to write down. First off, our theorem tells us that if two sides of the triangle are congruent, angles opposite the sides are congruent. Oh boy. Okay. Got to be able to do this part. The angle opposite side AB is C. Okay. The angle opposite side AB is C. Angle opposite side AC is B. And if AB is congruent to AC, then angle B is congruent to angle C. That's my theorem. That is true about every isosceles triangle. In an isosceles triangle, the angles opposite the congruent sides are congruent. My converse is also true. Converse being if two angles of a triangle are congruent, then the sides opposite those angles are themselves congruent. Okay? Let's see how we do with this. Miss Klein. This morning you were a bulldog, but that's okay. Camry, what side is opposite angle F? E what? Say what? Yeah, EB. Okay? How do I know how to go opposite? Start in the angle, draw a straight line until you hit the other side. ED, correct? Camry, what side is opposite angle E? FD. Start the angle, go all the way until you hit the opposite side. So these angles are congruent, and the sides opposite them are congruent. Okay? That is what my theorem states. Now, having said all that, check this out. I know that DE is congruent to DF. I know that angle B is congruent to angle C in this diagram. Talk real quickly about that vocab we just wrote down the slide before. What is the vertex angle going to be in this triangle? You got a 33% chance here. Here's a hint. The vertex angle is the one that's not part of the congruence. Which angle is the vertex angle in this diagram? The vertex. The vertex is A. Notice that A is not part of the congruence. The vertex angle is formed by two congruent sides. Two congruent sides form. Now, what do we call those congruent sides? Cameron? What will be congruent sides of an isosceles triangle? Leg. This would be a leg. This would be a leg. Okay? What do do we call this side down here? Base. Right on, man. What do we call these two angles? Base angle. Okay. Let's see how that works now. You are both have an action there, right? Okay. You gotta get that down for isosceles triangle. Yes, just a minute. Right after lunch. All right. Let's show you this example. It's okay. We can come back. All right. This says to find the measure of angle F. And at first it's like, yeah, I don't even know for one of them angles, Mr. Hobbs. And the triangle thumb theorem, I gotta have at least two of the angle measurements, right? Isn't that correct? That's what we taught you, right? Gotta have at least two of the angle measurements. Well, put our algebra caps on. If ED is congruent to EF, what is true about the angles opposite them? They're, instead of the same, they're what? They're congruent. Angle D is congruent to angle F. So now put that into our triangle thumb theorem. Here's the easy way to put it. When you're in math class, we ask you for a missing side or angle, what letter do you typically put there? X. Okay. So if angle D was X degrees, what would angle F be? X degrees. So that's how I can use this particular expression, or equation rather. X plus 22 equals 180. How many x's do I have? 2x plus 22 equals 180. Subtract 22, I would get 158. 2x equals 158. Divide both sides by 2. That's how I get 79 degrees per angle. Okay? All right. Let's move on to equilateral triangles. These should be easy as pie. All right, here's what you need to write, guys. If a triangle is equilateral, then it is equiangular. This is what we just talked about in the warm-up. You see why it has to be true now. The angles opposite the congruent sides have to be congruent. That's the theorem. It's really just, we just did the isosceles triangle theorem. It's really just the isosceles triangle theorem all over again, right? The angles opposite the congruent sides of the triangle are congruent. Here I just happen to have three congruent sides. Bonus question. We'll go to the dog pound here. Tell me this. What would be the measure of one of those angles? Yes, sir. What would be the measure of one of those angles in an equilateral triangle? 60 degrees. Okay. All right. 60 degrees. All three of them have to be the same. They all have to add up to be 180. That's how I get 60 degrees. My corollary, as they call it, if a triangle is equiangular, then it's equilateral. So if I give you a diagram and it has either three congruent sides or three congruent angles, you know it is an equilateral or equiangular triangle. Corollary is another thing for theorem or proof. Okay? Right? Here's the easy takeaway, guys. Equilateral equals equiangular. Okay, means equal. Yeah, means equal. Right? Time out, boss. Is this an equilateral triangle? Which means, is this an equiangular triangle? Which means, are all of these angle measurements 60 degrees? Yes. You see see all the things that are in place that they have to get through, right? So that's why 2x plus 32 should be set equal to 60. I subtract 32 from both sides, and then I divide by 2, and that's why x is 14. Right? See the process you got to go through, though? Yes, it's equilateral, which means it's equiangular, which means the angle measurements are all 60. Okay? And then comes the fun part. Then we put the algebra. Right? I'm going to give us, I'll give you 3 minutes. Nope, I'm going to give you 5 minutes, okay? Shoot, the timer will go off, but you're going to do these 4 problems. So, I want you guys to do problems 1, 2, 3, and 5. 1, 2, 3, and 5. No. How many sides are you growing? 3. If 3 sides of a triangle are congruent, good. Say it like that. Good. Congruent. What do we call it? A equilateral triangle. And in an equilateral triangle, my angles are all congruent as well. So it's equiangular. Each angle measurement in an equilateral triangle is 60 degrees. So I take 4x minus 20 and set it equal to what? 4x minus 20 is this angle measurement. What do I set it equal to solve for x? If these angles have to be 60 degrees, I would set it equal to 60 to solve for x. Now I add 20. 4x is 80. Divide by 4. X equals 20. Or bang. Okay. Number 5 is a tough one. Okay. Number 5 is a pretty tough one. Which is why Bradley is going to help me out. Mr. Bradley, how many different isosceles triangles do I have here? 2. Very good. Ethan, the angles opposite the congruent sides are what? 2. The angles opposite these congruent sides, what are they? Is anybody else from the dog town? Angles opposite the congruent sides are what? This explains a lot to me right now. They are congruent. So, Mr. Bradley, back to you. What is this angle measurement? It's not a very hard question. The angles opposite the congruent sides in an isosceles triangle are congruent. Say it again. The angles opposite the congruent sides are blank, and then I said the angles opposite the congruent sides of the triangle are congruent. Mr. Bradley, back to you. If this is 52, how much is this? Thank you. What do we know about these total measurements? How much does it have to be? It's a line. How many degrees are on a line? Mr. Mooneyham, how many degrees are on a line? 180. I've just given you 52 of them. How many are left over? How many? 128. All right. Here's 128 degrees. Mr. Bradley, back to you. Angles opposite the congruent sides in an isosceles triangle are congruent. So this angle measurement and this angle measurement are the same. This angle measurement is X. What is this one? Perfect. And the three angles have to sum up to be how many? 180. So X plus X plus 128 have to be 180 degrees. How many X's do I have? 2X plus 128 equals 180. Subtract 128. I'm going to give this away to you guys. 2X would be equal to 52. So, what is my final answer here? Somebody not what we talked about. 26. Okay. All right. Those are the types of problems that we'll be seeing today. Okay. Any questions on that?